All right, so let's continue our discussion on inequalities and absolute values. So now we're going to talk about inequalities. So let's look at an example of an inequality. So say we had 3x plus 1 is greater than or equal to 2 plus x. And we wanted to find all the x values that satisfy this inequality. So we need to solve this inequality and get all of the x's on one side by themselves. So I really like to have my x's on the left-hand side. So I'm going to move this x over by subtracting it. So that's going to leave me with 2x plus 1 is greater than or equal to 2. Now I'm going to subtract 1. So 2x is greater than or equal to 1. And then divide by 2. So I get x is greater than or equal to 1/2. So this is the solution to that inequality. Now let's graph that. So if we graph that, we're on the number line. Here's 0. We'll say this is 1/2. So we're going to have a closed, filled-in circle and then shade everything to the right of that, if that's on the number line. So that's what the graph would look like. And then in interval notation, that would look like 1/2, including 1/2, all the way up to infinity. All right, so this is 3 different ways of representing that same function. All right, so let's look at another example of a different type of inequality. All right, so let's look at this example. This one's a little different. Let's say we had -9 is less than or equal to -2x minus 7 is less than 5. So this is a special type of inequality. This is called a compound inequality. So notice we have things on both sides of the x. So we're still solving for x in the middle and to get it by itself. So first thing I'm going to do is add 7 to everything. So that's going to leave me with -2 is less than or equal to -2x is less than 12. All right. Now I'm going to divide everything by -2. But I have to be careful, all right? So when you divide by a negative, we have to flip the sign, okay? Or signs in this case. So we're going to have 1 is less than or equal to x is less than -6. All right, so written, or if we graph that, here's -6 and here is 1, then we're everything between 1 and -6. I really like to look at this as -6 is less than x is less than or equal to 1. That kind of makes more sense to me because the smaller number's on the left. So we're going to have an open circle here at -6. We'll have a filled-in closed circle here at 1. And we're everything in between those two. All right, so there would be the graph. And then in the interval notation, we would have -6 excluded up to 1 included. All right, so again, that's 1, 2, and 3 different ways of representing that same original solution, or the solution to that original problem. Let's look at one more example of this type, and it looks like if we had 3x minus 4 greater than 7, or 2x minus 6 is less than 2. Okay, so we have 2 possible things that we want here. We want x to be able to satisfy one or the other. So let's go ahead and solve these. So we get 3x is greater than 11. And so x is greater than 11 thirds. Or if we solve this one, 2x is less than 8. So dividing by 2, we get x is less than 4. So here we have two particular places. We have 11 thirds and we have 4. And so we can be bigger than 11 thirds or less than 4. So bigger than 11 thirds, less than 4. What you notice is this is all real numbers, right? Or we would say that's negative infinity to infinity. All right? So this is a little weird case that can happen sometimes, but this says that any number I plug into there is either going to fit into the first case or the second case. All right, so now let's talk about absolute values. And I really want to talk about the meaning of this symbol. So what this means is, this is the distance from 0. Okay? And another way to write this is like x minus 0. And the reason I want to think about it in this case is because I think of 0 as my center. So for example, if I had the absolute value of x minus 3 is equal to 1, then what I'm saying is I'm centered around 3 and I want to be 1 away from it. All right? One way to think about this is just guess and check some numbers. So like if I said, well, x can be 4, right? Because 4 minus 3, and the absolute value of that is equal to 1. Another possibility is, well, the x could be 2, right? So if I plug in 2 minus 3, that's the absolute value of negative 1, which is still 1. So that also checks out, right? So with these two cases, if I were to draw this, I'll draw 3, here's 2, and 4. Then 3 is my center, and my two possible solutions are 2 and 4. Now, this is not an interval. We're saying that exactly 2 and exactly 4 are the answers, not everything in between them. Okay? So let's look at another example. Let's say we had the absolute value of 2x minus 7 is equal to, I'll say 5. Then what we're saying is 2x minus 7 is our center, sort of, and we're 5 units from it. Another way of thinking about this is, what's the positive case and the negative case? So we can have 2x minus 7 is equal to 5. That would be the positive case. We're equal to 5 units above it. But what if we're 2x minus 7 and we're 5 units below it? Well, that would be the distance is negative 5. So if you solve these two cases, adding 7, then dividing by 2, so I get x equals 6. Let's do the same thing over here. So I get 2x equals 2 dividing by 2, x is 1. So I do get the two solutions of x equals 6 or x equals 1. Now again, look at that graphically. It's not as easy because this doesn't look like what we had previously. But if I won't go into that detail. We'll stop there. So moral of the story is to think about it in case of a positive and negative case and solve it that way. All right, so now let's bring everything we just talked about together. So let's talk about absolute value inequalities. Okay? So let's think about what the absolute value of x being less than some number, let's say a, means. So again, this is like the distance from 0. So here's 0. And we're a units above it, and we're a units below 0. So we have this distance of a. Okay? But since we're less than or equal to, just less than, then I can also be anything in between them, right? Because we're saying if our distance is just less than a, then I can be anything that's within a from 0. What this looks like is negative a is less than x is less than a. All right? So in short, the absolute value of x is less than a is another way of writing the compound inequality negative a is less than x is less than a. Okay? So if we look at an example, say we wanted to figure out when 3x minus 4 is less than 9. Well, then we would need to rewrite that as negative 9 is less than, let's do equal to this time, less than or equal to 3x minus 4 is less than or equal to positive 9. So add 4. So that gives me negative 5 is less than or equal to 3x is less than or equal to 13. Then divide by 3. So I get negative 5/3 is less than or equal to x is less than or equal to 13/3. Since I'm running out of space, I'm just going to write this in interval notation as negative 5/3 to 13/3. And then, of course, you should think about how to graph that to do that in WebAssign. But for brevity, I need to stop there. So we have one more type of absolute value inequality. So if we take the absolute value of x is greater than or equal to some number, then what we're thinking about there is, again, centered around 0. Here's a, here's negative a. Now my distance is bigger than a, so I want things that are farther away, so everything up there and everything up there. Then this is a way of saying that x is bigger than a or x is less than negative a. So here's where that or stuff comes into play. So if we look at an example of this, then we can say, well, what's the absolute value? Let's do something a little different. Let's do 2 times the absolute value of 3x minus 5 is greater than, let's make it even, 8. All right. So this time I don't have the absolute value by itself, so I need to first get rid of the 2, so divide by 2. So I have the absolute value of 3x minus 5 is greater than 4. But I'm going to convert this using what we had previously. So that's going to be, the first case is going to be 3x minus 5 is greater than 4, or 3x minus 5 is less than negative 4. Okay? So that it matches up with what we have at the top. All right, so what I have here, I'm matching here, and what I have here, I'm trying to match down there. Now that I look at it, maybe so let's write it consistently with what I wrote up there. So we would have negative 4 is less than 3x minus 5, so that we get the correct answer. All right, So I'm going to add 5 and divide by 3, so that's going to give me x is greater than 3. And then over here, I'm going to add 5 and divide by 3, so that's going to say x is less than 1/3. So looking at that, I'm going to have 3 and 1/3. I'm going to have 2 open circles, shaded below. So that's going to be negative infinity up to 1/3, union 3 up to infinity. All right, so there's our 1, 2, 3 ways of representing those absolute value inequalities. And that should take us through all of A6